Now, so we have really interesting material front. Now just move on to the equipment side. We have Homer Chen, who is a special assistant to CEO at SC New Energy. He's going to speak about the recent developments in PV cell coating equipment. And as you know, SC New Energy is one of the leading equipment maker supplying to the PV cell production. Homer, the floor is yours.
Oh, thank you. And use your how to share that. Okay. Okay, got it. All right, share my screen. So see my screen, right? Okay. Great.
Yeah, sorry, we are just seeing your computer, not the presentation.
Yes, I'm sharing now. Is it
Okay,
sharing now? Is it
not
sharing
yet.
now?
No.
Huh? Hold on. Is it sharing now? Okay.
Can you go into the presentation mode?
Yeah, I'm in the presentation. Yes. Hold on. Can you see my screen?
Not yet.
Can you or not? Yes.
No, not.
Hold on. Share once again.
Yeah, please.
How about that? It's working now, right?
Yes, yes. So please go
Okay,
into
great.
presentation mode. Yeah. Okay.
Okay, great. Got it? Yes. Okay. Okay. Hi, everyone. My name is Homer. And for the following sections, on behalf of our China SCs, I would like to present you some latest equipment manufacturing sites. Okay. First, Shenzhen SC, we are the number one ranking in the PV equipment provider in the world. Now we have 7,000 people, including 1,200 engineers and more than 600 patents. We would like to go for the one-stop shopping. What that means is we are not only for the high-tech business in China, then also we would like to acquire more advanced technology developer and also engineer and the new graduate for developing in the solar PV industry. We also cooperate with the OVAC and Sumitomo for developing the solar PV equipment. We have three major platforms. One is the wet chemical equipment that has been existing for more than 20 years. And now not only for we refine the texture, then also we have been involved in the semiconductor industry for the wafer cleaner. The second platform is the vacuum tube size. Okay, for the vacuum tube size stuff, we have all the tube equipments in this platform and also for the plate type, not only for the horizontal type and also the vertical type over here. The other tools are the smart factories. Smart factories, we have provided all the AGV and all the MES for the full factory automation. We can provide a turnkey solution and also including the latest, all the laser scriber and the slick holder for the perovskite solar cell manufacturing. The revenue, we have tripled the value, the revenue last year, but booking looks like only the double. So that means for the last year's situation is really a great blooming for last year. To the topic, first one is the TOPCon. As you all know the TOPCon already, so I just give you some information about what is being developed in my company. We have providing the two lines in order to cooperate the 1 gigawatt plant for TOPCon or PERC or something like that. We are now undergoing for one line and can fit with the gigawatt plant. This is the typical 5 gigawatt layout for order from our customer. And those are the configuration of the equipments that we provide, including the wet and also the dry equipment. Either we can accommodate for different kinds of the wafer size, and for the same throughput, there will be different configurations. I'm not going to the details. A little bit information about people are asking, oh, what's the new trend for having TOPCon, either by LPCVD or PVCVD. But then here, I give you the comparison table. So we are involving with the PVCVD, and for the past 1.5 years, we have succeeded in providing those solutions to our TOPCon customers. And we gained a lot of order from that. As compared with the LPCVD, we have a faster running time and also a higher throughput. And well, and typically, well, the maintenance cost for the quartz tube should be much lesser than the high temperature required for the LPCVDs. Then also some other comparison chart will be the precise in situ doping. Then also some minor little things like the how to separate the wafer within the tube or being isolated and make it more evenly. So that's why for all those achievements that we have for the past 2 years, we gain about triple time as the revenue. This is the trend data. For example, for within a week, the efficiency for the TOPCon will be an average 26%. This is in mass production, by the way. And then the yield is getting higher and higher. Okay, it's more than 98% now. So this is about the TOPCon, and then something about the heterojunction. As you all know that the basic 4 steps for having the heterojunctions, what we are doing is we kind of like a restaurant. So customer can get all kind of dishes from us. And for example, for the 4 steps of the heterojunction over here, for TCO, you can choose from the traditional sputter, or you can have our RPD. Some notes that the RPD is the original Panasonic, or more earlier the Shenyang, when they first start their first gigawatt production line, they are using by the hot wire and also the RPD to do the heterojunctions. But nevertheless, we can provide you not only for the plate type PCVD, hardware CVD, and also later will be have the tube PCVD will coming up. Something about the sputter. So the stubber, the non-uniformity, we are having a lower than 1% now, and about the coating thickness in non-uniformity less than 3%. The target utilization get to 85%, and the temperature non-uniformity within trace less than 5 degrees. All these points will give you some idea about the first solution or the general solution by the sputter. For our menu over here will be the 4 steps, and typical one will be the wet bench, and also the PCVD, sputter, and also the screen printer, all made by our company. So we are the turnkey solution provider. Also, you have the option for getting an extra gathering or the laser scriber for cutting the wafer by half. And also you can choose by the hot wire CVD, and also have the other one is to combine 2 together. And this is for the TCO, then will be another choice for the RPD, or the 2-in-1, the so-called the PAR modules. And later we'll have the copper plating. Originally from Panasonic, when they use the CAT CVD, they compare the CAT with the PCVD. We're not getting to the detail of that, but you're welcome to take a look. For these sections, it's quite easy to see that the COO for heterojunction, majorly for the silver paste. So the silver paste goes for the copper instead. In this case, we can cut down the costs for the heterojunction productions. But nevertheless, from the originally silver paste provider that I contacted before years ago, and the Kyoto guy said that the original silver paste should be less than 30% off. I mean, in 2025, but all other silver paste provider is catching up. Nonetheless, the other thing is to have the silver wraparound with the copper or the copper plating. There will be further reduction for the cost. And the third issue will be perovskite. That this is the typically two-layer structure for the perovskite for the glass substrate, then also for the tandem with the crystalline cell and as the bottom cell. So the so-called the conventionally structure, that's the positive the PRN structures, or reverse type, inverted type is the perovskite cell on top of the crystalline. No matter it's a heterojunction bottom cell or TOPCon. Okay, lately there will be TOPCon. So all we want to have is the define the structure that customer wish. Now we learned that there are so many compositions about the wafer layer structures, but nevertheless, there will be the ETL and HDL, typically for the tin oxide and the nickel oxide as a sandwich structure, and also plus with the same layer in between. And then on the wrapping side will be either tunneling for the TCO or on the cap layer of another TCO on top. But here we are now, for the past 2 years, we have majorly provided the equipment so-called the reactive plasma depositions, RPD here. Why we do that? Because the RPD can get almost no bombardment to the precursor layer. And also they look at the low temperature coating benefits. Now we'll talk about that a little bit. So for the glass substrates, for the 4 laser, now you can have the 3 wavelengths, or people are now trying to get rid of the UV and by using just the infrared and the green to cover the 4 laser scribing. And we are now providing the equipment as following. We can put 3 lasers in 1 laser scriber as an R&D tool, or we can provide 1 laser in each scriber and then make it as a line. Okay, so this is for the glass substrate. People has to know that a purpose of to get a larger substrate or the larger module is to compete with the major dominated crystalline modules. So nevertheless, the people now trying to fit in the 1200 times 2400 millimeter sizes. So this has to meet those sizes in order to overcome or penetrate the existing crystalline structures. I believe the gentleman has been introduced this before the last 2 sections. 10 years later, still crystalline dominates. So you will see the heterojunction and the tandem later. But every year we have observed the ITRPV report, and this portion getting bigger and bigger. So for the perovskite situation, it's kind of getting an entrance ticket to have a lottery or something like that. But nevertheless, due to the history about the OLED lifetime issues, still be the same as the OLED. I mean, to overcome the lifetime issues, then also the benefit or the future looking ship with the full color of the LED, something like that. But in the end, people are still always get to the BIPV situations. So this is the history. The lesson from history, then you have the CIGS, the Heading Terra, and also now the perovskite, they all become to the same film. The larger the wafer size, larger the module size, the less efficiency you will have. So by the pioneer, the leading customer over here for perovskite module. Now they are looking for 18 to 20% in the big, larger size over here. Why is that? Because the larger the module size that you need to have more precise coding when the coding size is being expanded. Because after the laser scribing, you will have the strip about all the cell connected to each others. So any defect in one cell will cause the current will not go through like a river. So this is the bad reason for this enlargement size, size. And also we have different customer for single junction or the tandem situation for 4-terminal or 3-terminal or something like that. And this is their developing story for either have the double perovskite layer or with a tandem with the crystalline. Eventually, they have to make it through for the light matching or the current matching in case like that. Well, a little bit comparison for the coating materials. What we are talking about is the RPD on the right-hand side. By comparison, for evaporating, still the neutral particles. For sputtering, for the gap so close together, about 8 centimeters, and you eventually the pre-coated area for the amorphous from the heterojunction or the perovskite absorption layer on the substrate will be damaged by the sputter. And this is essential. So introducing the RPD situation is an ion deposition because the similar to the evaporations, the sublimated particle will be ionized within the electron cloud. So close to more than 80% of the target particle will be ionized. So it's ion plating. Okay, so in this case, the high temperature will not even touch the substrate. And also the plasma area will not touch the surface. Let only the ionized, like indium or other things, to be coated on the substrate. So this is the beauty for no bombardment or the low temperature operation. And also I provided more detail about this comparison shift, more advanced benefit for RPD, not getting to this, but nevertheless, it will give you the evidence about the using the max energy analyzer, or you can use the Lambeau probe. For RPD, the ion with the high energy not existing in the substrate area. Okay, but for the sputter, you have a lot of high energy bombardment that will eventually kill the amorphous layer of the heterojunction or the perovskite absorption layer. So that's why the RPD have been so popular for the past 2 years. We have sold more than 2,000 machines about this in all kinds of configurations. A little bit more insight like this cartoon. On the left-hand side will be the sputter. The red dot is the argon. And eventually that will kill the pre-coated area. And for the RPD, because like a baseball, it's a long throw, all the plasma will be in the bottom part. What's left is the ion of the target. And also by using different target material, other than indium tin oxide, you can indium tin tungsten or the silicon, you will increase the 800 to 1200 nanometer transmittance. That will help for the tandem issues. And for our equipment, we can provide the 1 Hertz unit, which is, we name it as the 1000 series RPD. This is for R&D tool, and then with the production for perovskite and also the heterojunctions. Usually the perovskite is in vertical coater, and due to the wafer sizes and their holding, we use the horizontal type of the RPD unit. This is the best research tool that we name it as a SPE 1000T. So this is the cluster machines. We can combine either the cold evaporators and the RPD and also the sputter. and also the nickel oxide to overcome, to provide customer to make the testing with the substrate, available substrate of 450 times 650 millimeters in sizes to coat those areas. Okay, so different kinds of combinations and all the tools that we can provide for the last 2 years. So this is the whole line for the vertical type and the horizontal type. And now we are undergoing this year for the large size perovskite cell module productions. In the
Homer,
end,
okay.
yes,
So you just
last
have 1
page.
minute. Thanks.
Yes, last page. So what we have already, we have provide a solution for gigawatt level. And also we can provide a pilot line for try run of your perovskite cells. Okay, so and also this is the where I have mentioned that the variety of the cluster type tool that is the best for your choice. And thank you very much.
Thanks a
Any
lot.
questions?
Yeah, Homer, I think there are a few questions in the chat. It would be great if you can answer them, but I have one question. So can you comment
Yeah.
a little bit on the CapEx for the perovskites right now? Where do you see the CapEx for in comparison to heterojunction or TOPCon right now, the equipment CapEx?
Okay. Still, this is the sizing issues. Okay, the larger the size that I mentioned, the less efficiency. But people are in different track. They are trying to have the perovskite with the perovskite. Okay, they have different energy band to go for a higher efficient level. But also the other people is by using the tandem. In my personal view, in the long run, the tandem will surpass these big sizes because you have to know that the crystalline is still dominating in the module because in the end of the printer, you have the IV tester and the sorter. So you can screen your wafer. For tandem, you can screen your wafer too. So my personal view, in the end, the tandem will be much better than making a big size of the module. This being the history of more than 10 years ago when Applied Material tried to provide the generation 8.5 PECVD for the thin film industry. And it's not working, still back to the generation 5.5.
Okay. No,
Okay.
what I want to ask you is, what is the equipment CapEx for the perovskite? So how many million RMB per 100 megawatt line? Approximate, a ballpark figure.
I only can tell you that it's very, very expensive now. It cannot compete with the like a TOPCon or heterojunction. TOPCon in okay, so the TOPCon still the heterojunction capex is about twice of the TOPCon, and for the perovskite probably 5 or 10 times more. Okay, for a small capacity.
Oh,
Sorry, it's a
okay,
reality. But in the next few years, the capex will be dropped down tremendously. Yes.
great. Thank you.
Okay.
Thanks for this very insight. And I
Yeah.
think there are already a few questions in the chat window. Could you please
Yes,
stay
I
back
will.
and answer
Okay.
these questions?
I will.
Okay.
Bye.
Thank you. Bye-bye.
You're welcome.